Hello there, welcome again. Welcome back to the Technology Innovation Hub. And today we are going to have the third session of from Microservices Portal. We had two sessions, right? So let me share the screen, right? Okay, so last session you may remember that we developed REST API, very basic API, which is control and all, right? So just to say hello. So if I record that, so we use the screen tools for that, right? Remember, this is our program, and I have already uploaded it to GitHub, right? And shared in the video. You can take a look at all the documents also been uploaded now, right? So this is we know what it did, right? It just to display hello welcome, right? And we had another endpoint flash abc, right? So actually, even though it says a basic API, right? That's true because it has web endpoint, and we can use the URL, right? Using the default Tomcat port 8080. We did that yesterday. It's a kind of a microservice, right? It's a very small microservice because it has one method, right? It has one method, then it has one task, right? What is the task? So it says this is the method. So the task is to say hello, welcome. So as soon as we get into that particular microservice, the task is to say hello, welcome. It's a very basic kind of microservice. You can take it like that, right? It's okay, right? Okay, so with today's session, let's continue further, right? So now we have done up to this place in our document flow, step 2 and step 3 also. Step 2 is completed now. So let's start today with step 3. As I said yesterday, still we haven't got the definitions for microservice, even though we have been going around the things, but still we haven't got the definition. So let's take a definition, right? So not in detail, only the definition. We need to have that understanding by now, right? Let me open the document. What are microservices? Yeah. So we have what are microservices, right? So this is that, right? You can see it clearly. So microservices, yeah. So what are microservices? Microservices are an architectural style that develops a single application as set of small services. Microservice, it's okay. It's an architectural style, right? That develop a single application by combining a lot of small services or microservices, right? Each service runs in its own process, right? The services communicate with client and often each other using lightweight protocols, often over messaging or HTTP. So now we have a clear idea because this is what I mentioned by REST calls, right? In between microservices, the communication happens between HTTP protocol using REST call, REST API calls, right? We learned yesterday representational state transfer, right? So it can be a get call, it can be a post call, right? Get method, post method, right? Delete, right? Status likewise, okay? So this is a very basic definition. So we know microservices are small, tiny applications, right? In monolith, you may have one application which has several submodules. Whereas in microservices, each module can be represented as a microservice within the monolith, right? So those are independent, right? Independent means can stand its own. The relevant data to execute that particular microservice and get the output. The data part also there, or it can take it as a API call, as a service, right? As a web service or whatever. But whatever, to run the microservice, the relevant data part is there, and whatever the library support also. So it can survive its own, stand its own, right? That's right. It's not dependent on each other, and just because of one microservice fail, it's not going to fail the other one, right? So likewise, I mean, we are telling this one as a loosely coupled architecture, whereas in monolith architecture, it is tightly coupled. Tightly coupled means Now, if one module fails, that is heavily affecting the other module, causing the entire application to go down. So stability, availability will be in trouble, questionable. But in microservice, it doesn't happen. Just because of one service goes off, others are working fine, right? So loosely coupled, coherence is there. They need to communicate to each other, but loosely coupled. Okay, so that is what it says. If you go down further as an example, so this is what, this is a small example. You can see that shopping system without microservices. So shopping system without microservices. So this is a monolith architecture. So in monolith architecture, you can see web interface, mobile interface. So that means either from whatever way you can access it from the client, right? So, then server, you're going to have one whole application called shopping application. So within that application, you may have modules, store, right, configurations, right, and cart, shopping cart, right. Maybe this is to store the product items, likewise, right. Okay. So then this whole application works as one with this module, right, and it's trying to access the single database, right. So if something goes wrong in one of the modules, it might affect the others. So this is a monolith architecture. You all know this, right? And in if I get the same thing in microservices, right? So it's going to be something like this. So the front end is not going to change, like but the front end call is not going to right away hit the application. There is a design pattern going to be something called API gateway. API gateway. We will talk these things on later. This is one of the design patterns, right? I think yesterday also I told. All the requests are going to hit this gateway, then it will be routed as needed. Load balancing and those things can be implemented here, right? And you can see these tightly coupled modules as being decoupled now, right? We have a separate service for a small application or a small microservice for store. Separate small microservice for catalog, right? Or compig, whatever, right? The catalog is small, another small application for shopping cart, right? And each one has its own data component, right? We have separate DB here, separate DB here, but actually no need to be a separate database, but whatever it is, the relevant data component, relevant data, necessary data to receive this particular application will be here. Right? We may do API call for the database and we can get the data, but or else we can have a separate schema for this. It depends on the configuration. Whatever the relevant data will be available for the microservices that we can discuss later. Right? So that's the difference. So this failing this module will not impact this one. So it's still application is running. Okay. So this is just an example, right? So another one, why microservices is being used. And microservices were used to overcome challenges of monolith architecture that prevailed initially in the market and also enables you to deploy independent services. That's true. How does monolith architecture looks like? In a layman terms, you can say that it is similar to big container where all the software components of the applications are assembled together tightly packaged. All right, that doesn't matter, right? So that's okay. So let's you understand well now. Okay. All right, so I hope you got an idea about the microservice definition and the difference between the monolith and microservice, right? So let's keep it there, the theory part. So I'm going to close this. Then we are going to come to the other one. So I'm not going to go into details in this theory part because we need to do more practicals and come back to those documents. That's why the definition only within the is given. Then the next step, platforms for developing microservices. Platforms or the languages, right? Technologies, technology for microservices. So let's go through that document, technology for microservice, right? Technology for microservice, right? So this is what, now when you want to develop the application, you have to select using which language you are going to do, or is it going to be one language, it's going to be several languages, because microservice doesn't limit you to environment to one language like monolith. You can select your own and the technology platform. Right? You can read the document and see I have given certain details there, but I go through in brief. So being a business, you can see given below are some criteria to evaluate the programming language. So, I mean, this is somewhat, if you want to select whether it's going to be Java, whether it's going to be Oh, and in Python, so likewise. So these are certain criteria: culture of automation, highly observable, right? Support for automation, consumer first approach, right? Independent development, deployment, independent deployment, yeah, modeled around business domain, decentralized of components. So you can just get an idea on those things. These are theory. When you do practicals, I will come back to these things and explain little by little rather than just dumping whole lot of theory here, right? Okay, but anyway, let's see what are the most popular languages for microservices. So you have to start developing microservices as of 2021. These are the most popular now, right? Best languages for microservices, right? You can see Java is there, best language. Also, there are frameworks for developing microservices architecture. So based on Java, we have frameworks, right? It is all about annotation and it's all about annotation. What makes Java an easy approach? Yeah. So there comes, whenever we talk about annotations, the opinionated framework, right, with pre-configured Spring Boot, right? So these are popular frameworks at the moment. So our practicals, most of the things going to be based on Spring Boot because this is one of the demanding things, right? Spring Boot, right? So that is one of the platforms, one of the environments where you can start developing microservices. We have Drop Wizard, right? Restlet, Spark, those things also there, right? So that is one of the things, and we are going to base on Spring Boot, right? For our practicals. Another one, there's another one, Golang, or in shortly we are doing Go language, right? So Go language is another popular one for microservices. So I have given some description here, you can go through it, right? Yeah, for enhancement existing project, yeah. If you are enhancing existing project, it's telling that Go language is good. We will talk again detail. Again, we have Python, right? Python, I mean, even for AI, Python is popular, but even for microservices, yes, Python is popular, right? And some of these are as follows, right? Given below a broad range of Python microservice frameworks, right? So like Java, Spring Boot framework for Java, Python also have those things. Like Flask, Polkan, right? Bottle, Nemco, Verify, right? Okay, so just to give you an idea only, right? But depending on your requirement, you can select Python as well. Then we have .NET, right? .NET also there, right? To develop microservices, right? It's also popular and it supports .NET framework, right? Then we have Node.js. Yes, Node.js also much popular for microservices, right? And we have these key benefits of Node.js, right? Event driven, right? Bufferless, so highly scalable. So I'm not going to do a comparative analysis at the moment, but I just want to explain because these are the most popular at the moment for develop microservices as of 2021 now latest, right? So just get an idea, okay? Right, so let me again close this one and let's go to the next step, right? So next, what you have is step 5, Spring Boot as a technology depot, develop microservices. That's all. So we are going to use Spring Boot, right? Spring Boot. So let's go to that document, Spring L1, right? On, right? So Spring Boot. So that is what you're going to use. You're going to base on that, right? So Spring Boot is an opinionated framework, right? So that I have already mentioned, right? Tell how to build an app by providing most features and functionalities, right? It's a pre-configured. If you include Spring Boot startup form for JPA, right? You'll get auto-configured, yes, true. Auto-configured for it will get auto-configured for you an in-memory database, Hibernate entity manager, and simple data source. That's true. That is because it's talk about dependencies, right? If you include the Spring Boot starter form, yeah, that is because Spring Boot, I mean, the projects can be governed either by Maven or either by you can go with Gradle, right? So I show you in a while, right? So if you based on to go for Maven, the dependencies are managed in the form.xml. I think you saw it yesterday, right? Yeah, form.xml. I just show you. This is a form.xml file. For each project, if it is Maven driven, we are going to have a form.xml file, right? Let's open it up, right? For our project ID, we included one dependency web starter, right? Okay. Before that, I'll explain this. Before that, let's go back to our string IO, right? We go here, string IO starter, right? So here, now you can see the two types as I mentioned. The projects can be Maven driven or Gradle driven, right? So if it is Maven driven only, we have to depend on the form.xml file, right? And if it is Gradle, we have build.gradle file, two different ways to manage the dependency. So this project, since we started with Maven, so that's why our dependencies are managed from form.xml file. Now you can see we included only one dependency. We included this one. This you can see dependency spring framework.boot, right? And the dependency starting boot starter web. So we included this one, right? So once I select it, you can see in the right hand side it appears, right? So I mean, this is going to pre-configure certain things for you, right? For your requirements for your project, certain things are pre-configured. I mean, Java, library, it will automatically bring it to your project. So that's why your coding is very easy, right? And by this will facilitate that you can see in our program this one. This REST control and those things, annotations are facilitated via those things, right? Okay, so Spring Framework when annotation request mapping. Okay, right. That is for request mapping. Oh, let's remove this one. See, act or say REST controller. Okay. That's no need to bring additional import process managers. Okay, nice, that's fine. Okay. So anyway, that is form.xml file where all your dependencies will be there. So when you create the project, you can add dependencies. So later also you can right click here and you can say new, right? Not new actually. You can right click your and there's option called string. Under that add the starters, right? Here you can add the starters. Yes, it brings up the same screen. This screen comes even if you try to create a new Spring project. So here again, you can include your dependencies. Now, let's say if I want to include H2 database dependencies. So now it's going to add to my form and Lambok likewise Spring whatever, right? So let's activator, right? So likewise, if I say next and if I apply, so now it's going to bring those things to my project, right? So likewise, I can finish it. Right? It's going to include here, right? Okay, so already it's done now. So you can see dependency H2 database included, right? And I just asked him to bring activator also. It is also there. Okay. All right. All right. So that is that. The other thing I just want to show you. This one, if it is a Gradle project, I think in our note I have included that one. Let me check that because Spring recently did a change, right? Let me check. By my platform, Spring Boot technology developed microservices, enterprise beans, Spring Boot. Yeah, migrating from Spring Boot Gradle. Yeah, I have included it on step 8, right? Yeah, but let me visit here and I will show you that one. Yeah, let's go this official Spring Boot Springs project, GitHub project. Let's visit that, right? Let's go there. Now you can see all the dependencies. For Maven dependent, this is the Spring main project in GitHub, right? Now in there, because you know Spring framework is collection of I think there are 10 to 15 or 20 around projects modules are there. So Spring Boot is one of them, right? And if I click here Spring Boot, right, the starter web dependency which I just added earlier, right? So I should be able to find it from this place. You can see Spring Boot project, right? So I'm here, Spring Boot, then I go to Spring Boot project. Then here Spring Boot should be able to get Spring Boot starters, right? Starters, and then I should have Spring Boot starter web somewhere around this one. This is what I just added initially, just actually in the last session, right? And I added the S2 also. I can find those things as well. So now you can see the change, right? So now actually they should show here the form.xml file. But now very recently there is a change, right? They have announced this change. Let me tell you that. In the document I have that. Yeah, if you go to this blog, migrating Spring Boot Boot's builds to Gradle, right? Spring Boot built to Gradle. Now they have migrated the official GitHub. They have migrated to Gradle the builds rather than going for Maven, right? So if I just get in there, let's go here and see. Migrating Spring Boot project to Gradle. So this is the blog, right? Their official Spring IO blog. It says migrating Spring Boot's build to Gradle, right? So we made a fairly significant change to Spring Boot, right? In 2.3 node M1, instead of the first release to the project to build with Gradle rather than Maven. So that is what they have done. This is very recently, right? June 8, 2020, almost nearly year, but now as a result, you don't get in the Spring builds, you don't get the form.xml file. But earlier, even if you Google it, you will find in some of the history documents are there. These builds were depending on the form.xml file, but now it is not. It is on build.gradle. So your dependencies now goes in this way, because we will discuss this in more detail later, because in Gradle, the dependency management, I mean, very short code is low, right? Now, if in comparative, if you look at the form.xml file, right, to add the starter web, it has some, but little lines are there, right? So even maybe some 5 to 10 lines, but in Gradle, you may do it in 1 to 2 lines. So less code, less time. And what they are telling, you can see even in the blog, they have mentioned the same. This one they are telling as to why did they switch? Why did they switch? Because the time and the performance, they are telling it is higher. Build time, right? So you can go to this blog. I will include the document. I'll upload it to the GitHub. So just take a look at this is a change that they have done recently, right? Okay. All right. So let's get back to our discussion. Yeah, so our document, this one, yeah, this is also our base document, right? So yes, this is Spring Boot comes up with quickly bootstrap starting developing Spring Boot based on application towards. And this is I have explained the S2 built-in database, right? So it has S2 built-in database. It has built-in Tomcat web server side, which makes us easy for Java JPA, right? For in S2 database, if you are dealing with database activities with JPA, it will be much easier for you to Spring Boot, right? So this is a comparison between the Spring framework, the initial original Spring, and the Spring Boot. I have included a comparison, right? So just go through it. I don't need to go one by one because as the things are developing, we will see the benefits of Spring Boot, right? And not just no point of going through one by one the detail. I mean the benefits in theoretically. So here, for example, in Spring to test Spring project, we need to set up the server explicitly, because there was no built-in servers like Tomcat in Spring, but in Spring Boot we have things built in. So I mean, you can just call the H2 dependency, and the annotation will come up, and database is ready for us, right? So that's what. So and again, that's you can just go through it. Spring and Spring Boot. Again, I have included comparison between Spring Boot and Spring MEC. We haven't talked about anything on MEC, the model view control. I have just mentioned few words on MEC. So again, there's a comparison because Spring, what is this? You can see the very first one, Spring Boot. Spring Boot is a module of Spring for packaging the Spring-based application with sensible defaults. Module of Spring, that's true. Spring MEC is module view controller based for web frameworks under Spring framework. So this is mainly for web. We know that MEC, right? Mainly for web, and this is just a module. That's true. It's not. I mean, yeah, that's what it is. It provides default configurations to build Spring Power. We need to do some. It provides ready-to-use features for building web applications. So don't worry about Spring MEC. We are going to discuss in greater details later. Sorry, right? So Spring MEC we are going to discuss in great details later with some practical examples as well. So till that, I'm not going to go into more detail, but this document will be there. Just take a look at if you are very beginners to these things will be helpful for you to understand the things, right? Okay, right. So let's go to the other one. So we were on Spring Boot, this one. Then we come to the microservices example. Okay, now we have gone through one example, right? And we have done a very basic API, right? So now today let's go to the another next step. Let's go a little bit advanced. I will show you some examples of microservices, right? So I will go to, let's do it. So this time let's use IntelliJ, right? Let me open IntelliJ, right? We use Spring Tool Suite now, right? So let me open IntelliJ. And we'll take a look at, I'm using 2021 latest, right? So we'll take a look at two microservices, right? I'll show you. Right. So this is this code, very small one. You can see. Okay, this is a microservice for payment service, right? Payment service. You can think about as a e-commerce application, right? For items to pay when you purchase or whatever from stores, right? So it's a microservice, payment microservice. So if you just go into the code, right? So I'm going to open source main and Java, right? Okay, so my main Java is here, right? And it's a Spring Boot annotation is there. As soon as you see that, it's come from a Spring Boot application, right? And you can see I have 4 packages, 4 Java packages. Within that, you can see I have something called payment controller, right? If I go in, again, I have REST controller and I have a mapping, request mapping. But we just learned this in the previous session, right? But it is a bit of enhanced because this is going to do some work, right? Means, I mean, earlier it is just to display hello, no, but now it is not that. This is going to handle some payments, processing, right, as it receives, right? And you can see the payment. I have the entity. This is for my database, right? So because I have a table, no, right? So I have, it looks like database is not accessible. That's why it's highlighted. That's fine. That's okay. So I have a database called payment DB is a, maybe, yeah, it's a table. I have given the table annotation, right? So, and data, and I have these columns, right? So like this. So I have something called payment ID, payment status, and transaction ID, right? And again, there's repository. This is for JPA part, right? Yes, to connect with the database, right? Java assistant, and I have the service, right? This one, service, payment. When a payment arrives, how to handle it, right? This is okay. Anyway, what I want to show you, this whole code will represent one microservice, which is going to handle payments in maybe e-commerce system, e-commerce application, or whatever. No need to be e-commerce, right? Whatever, wherever item requires a payment. Just to give you an example, right? And okay, entity and okay, right. Let me show you another one. Right now, this is for payments. No, let me open another one for something called orders, right? Orders microservice, right? So yeah, this is order. Let me open that one. Open a new window, right? So similarly, I have the same structure for another microservice called order, right? So if I open that one, right, and all are depend on this. These are not Gradle. This is all are form, right? Maven, right? So if I have run this one, well, that's where the target folder. That's okay. So again, if I go to you can see source, main, Java, and again you can see I have the similar structure. 4 packages are there: controller, entity, service, and this time for my service application, service microservices, right? And again, you can see the entities, the table is there, and there are columns, right? And if I get the controller, my endpoint, web endpoint is there. Right? You can see I can go to like the same, like in the previous session, localhost /order, right? /order1 in this case, and book order. There's a postmap in as well, right? So yes, looks like there's a syntax error here. I can correct it, but let's leave it as it is, right? Auto-wired, can check what it says, right? Not there, no need to be that much, right? Loaded door. Yeah, for the REST controller, yeah, that's okay. No, not this. It should give the suggestion. Anyway, this what appears here, right? So here what appears, the same thing should appear for this one as well, right? But it doesn't matter, it's okay. Right? Order controller, right? So yeah, you can define exclusive method for this, that's okay, right? That's fine. Anyway, right? So there is another microservice, right? There is another one. So I just show you 2 microservices, one for payment and one for order. So not to worry, just get and try to get an idea. I'll upload this code as well. So just get an idea what are microservices and all. That's why I just want to show you this thing, right? And later we'll be developing these things from the scratch. So no worries. Right? Don't worry about it if you don't understand what it is, but just get a know-how. This is what is microservice is. This is a microservice, right? And we'll develop from the beginning, then you will get to know this detail. And okay, in the next session, right, I'm going to show you a migration as well, because you can see, then you can see the comparison. Then it should be much clearer. Now, this is only a microservice I'm showing, right? But here, you can see in our document flow, now we are in step 5, right? Step 6, enterprise solutions. Okay, what are microservices? That's okay, and it's being MVC. There's a small explanation for that one. And here we have the migration, right? Migration. No, this is that migration I just explained from Maven to Gradle. That is something Spring Boot has done. But on step 9, there is something called example workflow. Why migrate request? Now here I'm going to explain you by comparing 2 codes, the monolith code and the microservice codes after migration. The old traditional monolith code and the migrated microservices code. Then you will get the real feeling of what the difference is, right? So actually that's going to be the last thing on this introductory session that I'm going to do. I monolith to migration example, right? So I mean, we'll be able to do it in the next session. So then you will get the comprehensive idea, but for the time being, just get an understanding. These are microservices, right? Like that. That's why I just show you two examples: payment and order. All right, right. So with that, I'm going to stop here for this session. So we'll meet in the next session with another migration example as well, right? So all right. So if you like the video, put a subscribe, right? So okay, thank you very much. Then have a nice day. Okay, bye bye.